Okay, continuing on with the Denon transport rebuild. I've got the head leads removed. The faceplate off. And just want to remove this little ribbon cable to make my life a little easier. And we'll get this transport out. There she is. Okay, let's get this chassis out of the way. And there's my transport with the broken door. And if I can zoom you in on this, I can show you the part that's broken. There it is right there, that post. Right there. That one. So I have a plan to repair this. I have a couple different thoughts, but the first thing to do is replace that post. Now before I get started on that, I want to remove the capstans and the motors and get one more step along the disassembly line, but I also need to measure these belts. I can't find a spec for them. I did find one, but it was kind of dubious, and so I want to actually do the measuring of the belts and then get the belts ordered. So removing the capstans, you already saw me clean them. I don't ever want to pull a dirty capstan through the bearings. That's not good practice. So we clean them first and then pull them out. And just to make it easy, I kind of bump them a little bit and then remove the oil seals. Take the capstans out. And that's an interesting arrangement on the grounding of that capstan bearing because it's installed in a plastic overmolded part housing. And so they've grounded that for static reasons, I suppose. And I don't really like that, and I will probably change it because I've had experience with flat spring ground straps in the past on other equipment, and about half of the time I found it to be the cause of the intermittent fault I was chasing. So I may make some adjustments to that or find a better way or an additional way. I don't know. We'll have to look at it. Okay, let's look at these capstans. They initially they don't look bad. They really don't look bad at all. This looks like just normal wear to me. Try to get you focused on it there. I don't know. I may clean that up a little bit. I may look at the balance on it. We'll see. There's no grooving that I can feel anyway. No, I think we're in pretty good shape on these. I want to be able to get to this idler pulley and see if I have the correct tire in stock. This transport resembles other Denon transports that I've worked on, and so I'm kind of hoping this is one that I already have in stock, and it looks very similar. These are an oddball one to find, and what I've found is a slight modification of an existing component can do the job on these with no problem. So let's measure it up and see if I have the part in stock. Okay, so it looks like it's pretty much 17 millimeter OD, 2.5 on the width, and more than likely it will be 11 on the ID. Now, it's not necessary to use tools to remove these, and it's sometimes can cause problems and break flanges when, you know, a screwdriver or something's put in there. I just pull on them and get them out, and it's not a problem. So yeah, this will be a 11 millimeter ID, and that's the conventional Denon part I've dealt with, and the one that's impossible to get. So the solution I have here in my shop is the one that I'll employ on this. Yep, pretty much 11 millimeter ID. Okay, I'm satisfied with that. Let's move on to the other bane of some of these transports is the overmolding and its associated runners and sprues. And you can see what happens with these is they shrink and crack and break over time. And what I like to do to prevent them from, you know, breaking off in the future and gumming up the works is just cut them off, break them off, and, you know, get rid of them. Just want to get underneath this gear. Again, this is conventional with what I've seen in Denon transports. Really, I don't, you know, seems to be a good design because I don't see problems with this. I don't think I've ever repaired the control, you know, mechanism on these. It just works. Okay, so we've got a couple more there to deal with. So, off with their heads. Yeah, I think I'll just cut these off. That's the easiest way to do it. they're so thin and so brittle, it just doesn't take much. I'm not a big fan of this. It's on a lot of transports, but what can I say? I don't like it. So the point is, I'll do what I can to deal with it and make it so it hopefully doesn't cause problems in the future. That's about all I can do. Okay, so while I'm here, let's get the rest of this apart and see if there is something else I need to try and find and order, manufacture, whatever. Get the reel tables off. So you can see that the deck's very clean. There's not, gosh, sometimes there's so much worse than this. This is a very clean transport. Everything about this deck so far has been very clean. I expect it to be a good performer, a great performer, actually. I'm thinking I need to get these levers, whatever, out. It's really not possible without that overmolded piece also coming out. They are captured in there by the vertical metal part of the transport, and in order to get them past the point where they can slide through that part, they need to go down farther than what they're able to come down. So this is an interesting bit of engineering that I'm trying to kind of reverse engineer in my mind so that I can understand how they put this together. And it's, very possible that they relied on the resilience of the plastic when it was first molded to be able to take the amount of force needed to install them. But at this point, after, this many years and the plastic curing and drying up and becoming more brittle, I'm not willing to, assume the risk of removing them. So, and I felt like I need to remove the one to get to where I needed to be. But, so this is a pleasant change. They actually used E-clips to hold these down instead of those horrible plastic split washers. And that's the interior thrust washer. It actually looks like either looks to me like a kind of a Nylotron product. So the grease is still supple. That's good. Not a problem there. Denon, I will say, Denon did use, on everything I've dealt with, they did use a high quality, probably synthetic grease that did not turn to goo and glue after years of use. So I have to give them credit for that. That grease was probably, aerospace, or on the cutting edge of aerospace, or cutting edge of commercial lubricants at the time this deck was made. So it would have cost them much more than a conventional lubricant at the time. All right, so this all looks very good. So bar bearings. Now, one thing I want to get this head stack out and this whole assembly, and you tell me how it comes out. I don't know. It's captured underneath those two overmolded rails on the left and the right, and it can't go north, it can't go south any more than it's going. You can only move these things so far before they break and crack. There's nothing on the back that helps me. As always, we can force something to a point. And the question is, where's the point? And I'm trying to understand the engineer's design while I'm doing this, and I'm thinking, why? Why would they put this together in this fashion? We've all been there. I'm there every day almost, but I can't see anything that will help me remove that assembly without, possibly cracking those guide blocks. So, okay, maybe if I get that one, maybe if that one can move farther up, it's possible. I don't know. I'm just showing you what I went through. Okay, so I was brave enough and I got it out, but I am no way comfortable with that procedure. And I want a better one to put it back in. So maybe if that plate has, more travel, it will help me here. So I think what I'll do here, I think I'll remove that capstan bearing. It seems like that's what's holding me up. So I'll put a mark on it so I know where to clock it. I'll actually change that position. I'll put it onto a fresh position when I reinstall it, since I'm taking it out. And so that will help me know which position it was in to begin with. So that's a nicely made part. But then you can see on the other side is an overmolded component with a pressed-in brass, oilite bronze bushing, and then that silly flat spring ground strap. All right, let's see if this is any better. So it looks like if I kind of slide it in the left channel first, then I have sufficient clearance to bring it into the right. Let's see. Yeah, so that seems to work. I don't like it. I don't think that's a smart design at all. And what did it save? It saved, what, a nickel's worth of ball bearings and screws. I don't know. I design stuff too, and I design stuff to be easily serviced and maintained. And this is not a design that I would ever have thought of to try and save 5 or 10 cents on manufacturing costs. Nor would that supply side capstan bearing system come to my mind to try and save a few cents. Okay, so rant aside, let's move on. While I'm working on that broken post on the cassette door, I want to have a look at these motors, see if there's any work to be done here. That's capstan drive motor, looks really good shape. And so what I'll do is set these in a position, lubricate those front bearings, and let that soak in while I'm working on the other part. Again, I'm using this Nioil lubricant. You can look up the properties on it. It's a very fine, filtered, it's a great lubricant for this sort of thing. And I'll do this on each front bearing, and I'll probably do it twice since it will be sitting here on the bench and I'll be working elsewhere. I don't see a rear entry into any of these motors for lubrication, so the front will suffice. Okay, so here is the cassette door set up in the mill, and I've got it vertically centered and parallel. And you can't see the other direction, but it is on a also a precision V-block. And I need to flatten this damaged surface, which is where the post broke off. And incidentally, I did find that post in the chassis, and so I know my length that I need to duplicate, which is a good thing. So yes, I am running an end mill in a drill chuck. Get over it. All right, so I've got a nice flat surface to work with here. And that's what I needed. Now what I need to do is get centered up on this boss. I know you can't see this very well, but I can see it, and I'm the one that needs to see it. If a part is truly round or very close to round, I only need 3 ends on which to zero. And the fourth one, if it's round, will be 0. So here I am, I'm working it in, and I'm happy with this. This is just my little support on the back. So now I'm centered, I'm dialed in, and I need to give myself a center mark. I'm gonna loosen my quill stop. This is a Cincinnati, and the quill stop is a hard stop on these. Okay, just give it a little center drill. Now I looked around the shop for what miniature screws I had available to me, and taps, but mostly the screw is what I was concerned with. And here's a number 4, a number 440, way too big for this application. And number 4 is not all that big. Here's a number 3. Again, this is way too large. This is number 2, and this is approaching where I'm comfortable with, but I still think it's a little bit too large. Now this is a number 172 tap, which is getting closer. I'm liking this number here. What I'm shooting for is somewhere around 1/3 of the diameter. And I'm going by eye. I'm not measuring here. This is by eye. This is a number 080. It's fine. It would be nice if I could get a little bit larger than this. I like the 172. This is my preference. I like this one. When I say 172, that's a number 1, 72 threads per inch. SAE. So I'm set up to drill this out. When I went to look for a 172 pitch cap screw of sufficient length, I didn't have it. I had shorter ones, but I didn't have one in the length that I needed here. So what I ended up converting to was a 2 millimeter metric. I think it's 150 pitch, 1.5 pitch. For anybody that's keeping track. Anyway, so what I ended up with was that 2 millimeter cap screw in place of what I originally wanted. And this is the correct tap drill for that 2 millimeter thread. Okay, I just needed to get my stop out of the way, but still have a little bit of support there. Okay, so this is the tap that I decided on. This is a form tap, not a cutting tap. And this is actually a really good thing in this application. It's what I had on hand. We'll just chamfer that hole, give it a running start. And I'll use my tap follower here to keep it axially aligned. Get you in closer. Boy, I hope this is all in focus. I hope you can see this. I'm doing my best. Okay, so the tap follower keeps it axially aligned and also keeps a bit of downward force on the tap. And what I'm noticing here, I'm getting a little bit of, I'm getting something I don't like here. And what it is the burr on the exit side of the hole that's interfering with my spacer blocks. So I just need to get rid of that burr. I just kind of noticed that it was rocking while I was trying to tap it. And that's never a good situation. All right, that took care of that. And yes, see yellow, what do they call it, safety paint on my fingers. That's because I've been painting yellow safety paint. Okay, that'll work great. This has a good feel to it. There's very little pressure running that tap down in. Obviously, it looks big on screen. This is a tiny tap and a tiny hole. I just move that out of the way so I can go through. Now, while I'm doing this boring part of the project, I'm going to put a plug in for this software G-Wizard machinist calculator. This is something I've been using for years. I bought it. I'm not getting paid for this or anything like. He doesn't even know I'm doing it. I'm just showing this for anybody that might be interested in a piece of software that really helps out in not just a machinist shop, but a whole lot of shops. This is one section here, the threading section of this entire suite of software. And it's helping me to know, you can see even on the form tap, as opposed to a cutting tap, it gives me an idea of how much thread depth I want to get to and the correct dimensions and tap drills to get to there. So that's all that is. No promotion here, but you guys did a great job. G-Wizard, thank you. Yeah, you know, right. If this was a cutting tap, that would have pulled right out of there, but this is a form tap, and I've got to back it out with a little bit more force. Okay, there we are. Very good. And again, let me just emphasize how tiny of a screw this really is. I can barely even grab it. Okay, and then this is how I've had it clamped into this was a V-block that just happened to fit perfectly this cassette case. Well, let's put our stuff back in order and then move on. Now what I need to do is turn the new post and bearing, I'll call it a bearing, so I'll just reposition that in the chuck a little bit and try to get it zeroed. I've made a little drawing of the part I need to machine, and don't follow that drawing because one of the numbers is incorrect. I think I'll just fast forward through all this because it's just typical machining. Nothing special here. Maybe I'll say a word about the way I do things in my shop, which is to turn the OD to maybe say 15 thousandths oversize and then bore. and then get the bore to size, and then go back and finish the OD. Now, I don't do that universally, but that's my habit because it tends to give me a piece that's not warped, and it's worked out for me. Now, sometimes I'll do the bore first and leave it heavy, and then go back and do the OD, take that to size, and then go back and take the bore to size. It just depends on how the piece needs to be held and several other factors. But my default is to take the bore to size, to take the OD oversize, and then to take the bore to size, and then follow up with sizing the OD. It's just how it works in my shop. Okay, so there's the post. And it fits the cap screw well. So now I've got the bearing to turn. So again, I default to going slightly oversized on the OD. It's just, I don't even think about it. This is just, unless it's something very special or very specific, this is my default. Okay, that's center drilling. And then in this case, I'm going to undersized drill. And this is just to get a little bit nicer finish on the final bore size. Okay, that fits my post, but I lost it, so I got to get it out of there. Okay, so now I'll do the ID or OD and the flange. It was not necessary on a part like this. It's just my habit. And so chamfer inside and outside. Polish it a bit with a Scotch-Brite red, and then a piece of leather with some what do they call it? Jeweler's rouge embedded in it. Okay, chamfer the outside of it, and there we go. There is our bearing for the door. Yeah, just chamfer that. Let's give it a try. Okay, there's our broken post, and did I mention how small this was? Okay, there is the new replacement post, and again, I did find the broken post, so I know the size, the length of it. And there's the bearing. Of course, this will get all greased up and so forth. But that's how that works. And then what I based my calculations on was the other side that I taped on there too well. Okay, so there's what the other side looks like, and then the other bearing, the plastic bearing for the other track. And that's kind of where I got my calculations for this track, or this bearing. Okay, so the way this works, finally, is just like this. So I think this is actually a little bit of an improvement over the factory one. I think it feels a little bit more positive. Of course, this will all get greased up. But that's the first part of this repair and overhaul, and I appreciate you all watching. Stay tuned for the next one. Thank you.